and then I stopped the recording for the time. All right. So what we're going to do is that I put you guys all in one room, and what is going to happen, some of you know more than the others, and the other. Remember, nothing is being graded, nothing being judged. Everything is just about learning. We go at your pace. If you need to go pull back, I pull back with you. If you need to go forward, we go forward with you. And Juliana can tell you what I'm talking about, right? So, and nothing says that you cannot help each other. In fact, you should, okay? And ask each other questions, and I'll come to you back and forth. I'm going to set up Kevin and Isabel first, and then I come to your room second. Fair enough? I'll be right there in about, let me make up the rooms first. I'm going to create 2 rooms. Why doesn't it let me do that? I don't want 9 bedroom. Okay.
Yeah.
Add
You
the
have to be
room.
the superpower. Oh, you can do it.
Let me do it now because I did something weird. I don't know what I did. So I'm going to put. Go ahead, say it, Kate.
Can you enable sharing, please?
I will do that too. Definitely.
Thank you.
But since you're co-host, couldn't you do that now?
I think the way I joined did not make me co-host, but I could rejoin as co-host. Yeah, I'm in that habit yet. But yes, I was delivered that power. I haven't used it yet.
Okay. All right. So let's do that. I am going to open the rooms.
I'm going to rejoin on a different account.
Oh, that's okay. We'll figure it out. Those are minor details.
So you're
all right. I have all of that. The rooms are open, and I'll be with you. I'm going to go to room 2, and then I'll come to the other room. Okay. The next part of the problem I want you to do, and then what I like to do is the next part is that from here, I measured that angle here to the bottom of the flagpole, and that angle here is 35 degrees. How long is the flagpole? What's the length of the flagpole? Oh, let me change the camera angle so you can see it. Okay, I go from here to there, and that's 35 degrees. The question is, how long is the flagpole? Got it?
The first question.
You can go to the other room so that you're not here by yourself. And because they're going to get this problem eventually. Okay?
Yeah. What was the first question?
Sorry?
How long was it? Was the first question how long it was from the floor to the top?
The first question was how far is it from from the ground to the top of the flagpole? The second question is how long is the flagpole itself?
Got it.
Okay. Okay. You can go to the other room with them. I can let you in there, or you can join automatically. Go ahead.
Okay, but that would mean that I have to have the other answer correct first.
Well, you can stay here, whatever you
Okay,
like.
fine, I'll go back. Yeah,
Well,
because
I
these
just
problems are hard because you have to make sure you have the other answer correct first.
say your microphone was not functioning.
Oh, can you hear me now?
I hear it is vibrating a little bit.
Oh, what about now?
It's getting tiny bit better.
Oh, no, I'm just going to the other room then.
Okay. See you there.
Okay.
Okay. Let me change the camera so we can talk. Where's James? Okay, let me go see what happened to James.
Probably still in the breakout room.
Oh, he stayed there.
I think so. Do you want me to go back in and check?
I am there.
No. He just wants to go find you.
Oh, I wasn't sure how to get in here.
You're all good. You figured it out. Yeah, he's back. Yep, there we go.
I was chasing you.
All right.
James. Okay. Now I want to explain to you some stuff first. All right.
Okay.
I'm going to start with what we did in the morning about the triangle. Remember?
I missed the morning class. I went the afternoon.
Well, in the afternoon. You were there in the afternoon, right? Okay, we did that in that. Juliana, you came in the afternoon too, right? Yeah. Okay, let me show you. I'm going to erase this for a minute. Let me start with the triangle that we had. Okay. This morning we did the and this was 90 degrees. Remember? Okay? And we labeled it A, B, C. The good thing about this triangle is that all the angles are less than 90 degrees. You see it? This is 90, this is less, and that's less. And in here, we wrote the ratio A, B, and C, and the sign of the angle C was what? Was the sign of angle C? Well, I'm sorry, let's go. We did it with this one. Did we do that with the B? What's the sign of B? Do you remember? From this morning.
Oh.
Was the opposite over hypotenuse, wasn't it? Opposite over hypotenuse. So it would be B over C. Right?
Sign.
And what would be sine of A?
Hypothesis.
Remember, sine is opposite over hypotenuse.
Is
One
it
of
A
you
over C?
say it.
Is it A over C?
Exactly. A over C. Okay. What is the cosine of B?
Is it adjacent over the hypotenuse?
Yes, and what would that be?
Sine B. Is it?
Can you see the board?
Yeah.
So what would it be?
C would be on the bottom, correct?
Yes.
And then would it be B? Or
What is it? A?
oh, opposite. Or no, adjacent. So it would be A.
Yeah. Okay. So you see that cosine of B is equal to sine of A.
Yes.
You see that?
So cosine
What?
B equals sine A.
Cosine of B is A over C.
Mhm.
Sine of A is A over C. So that tells you that cosine of B is equal to sine of A in that triangle.
Mhm.
So there are other relationships between them. You see it?
Yes.
Okay. Of course, two things I didn't tell you. What would be the cosine of C? If you were going to look at it, cosine of C. It would be kind of interesting to look at. That would be a hard one, won't it?
A
Because the cosine of C, what would it be?
A over C? Or no?
It's hard to do, isn't it?
Yeah.
Okay. I could, you see the problem?
Mhm.
And in fact, for 90 degree, cosine of 90 degree is always 0. Okay. What is the sine of C? That's a more interesting one.
Professor,
What is the sign? Opposite, right?
I have a question, Professor. How
Say
do you
again?
get how do you get the cosine 90 equals 0? How did you get that?
I will show you in a minute, okay? Just hang in there with me. What would be the cosine of C?
Would it be B over C?
No, it has to be opposite. What is the opposite of the C?
A.
Here's this angle C. What is the opposite of it?
Oh, C?
C. So it would be C over C. And how much is that?
It's 1.
1.
So sine C
So-
equals 1.
So sine of 90 degree is equal to 1.
This is
Okay,
only for right triangles, correct?
that everything for the right triangle.
Okay.
Now, James, this morning, let me erase this for a second.
Mhm.
This morning we proved something very important. We proved that for any angle, sine of the angle squared, any angle, okay? This could be A, B, or C, whatever angle, plus the cosine of the angle squared is equal to 1. Do you remember proving that this morning?
I remember this one in the identity, the trick.
Yeah, we use the Pythagorean theorem. The fact that a squared plus b squared was equal to c squared.
Wow, okay.
Remember that?
Yes, thanks, Professor.
Okay. Now, so if I have sine of 90 degree squared plus cosine of 90 degrees squared is equal to 1, right?
Mhm.
What was sine of 90 degree?
1,
What did we come up with the sine of 90 degree was?
1.
1. So I have 1 plus cosine square of 90 degree is equal to 1. This is for James' benefit. So what does that make cosine of 90 degree to be? 1 plus something is squared is equal to 1. So what that something has to be? What should this be? 1 plus something is 1. What is that something?
0.
0. So that means cosine of 90 is 0. You see it? I saw a smile on James' face because we got it.
Let's see. If I go back on the board, you have sine squared theta plus cosine theta equal 1.
Cosine square equals to 1.
Cosine equal 1. And then the bottom line, the formula coming in.
Well, this is true for any angle, right?
Oh,
So it has to be true for 92.
so any angle, even 45, 35 is still
Any angle.
right. And then I forgot how you get 1 plus cos to second.
On substitute, okay. I just showed you this was 1. I remember we said, well, let's go again. What is the sine of, in this case, what's the sine of C? This C, remember C is 90 degree. Sine was what over what?
Oh, sine 90. Sine 90.
So what is the opposite of this angle?
Opposites. The opposite will be B.
C. For this
Okay,
angle,
C.
not for that angle, for this angle. Opposite of it is C.
Yes. Mhm.
So it would be C divided by hypotenuse. How much is the hypotenuse? Isn't hypotenuse C also?
So right now we have to see the opposite. The
But
hypotenuse.
for any angle, the opposite of it is going to be, for example, let me go to you again. What is the sine of A? A is this angle, right?
Yes.
So what is the opposite to that angle?
The letter A, small a.
That's correct. Divided by hypotenuse. What's the hypotenuse in my picture?
Yes. Okay. Hypotenuse will be the C.
C. Okay, what's sine of A?
Sine of A will be
I'm sorry, B. We did A. The
cosine of sine of B will be sine
Opposite. What's the opposite of
of
B?
small b
Divided by
by C.
hypotenuse.
By C,
C.
small c.
Okay. So now what is the sine of big C?
Sine of big C will be 90 degree equal 1.
Well, it's 1, but we can prove that it is 1. Because opposite is C and hypotenuse is C. So C divided by C gives you 1. Okay? Okay, you guys hang in there for a minute. I'll be right back.
Thanks, Professor. Thanks for showing me that.
No problem. But here what I want you to do. Suppose I have an angle, okay? Okay, I have an angle which is 50 degrees. Okay? So, now here's what I want to do. Suppose sine of an angle, I don't know what the angle is 0.30. Find cosine of that angle. So find the cosine of that angle. See if you two can figure that out. Okay?
Okay.
You have all the things you need at your disposal.
Thank you.
Julian, I have a question. So the question just wrote on, we have sine angle equal 0.30.
Yes.
Do we need to draw the triangle, or do we need to draw it?
I do not know.
So sine, so if I look at it, we know sine is angle theta, I mean sine theta equal opposites over hypotenuse.
Mm-hmm.
And now we would need to
Sine. What did you say? I'm so sorry. Could you repeat that?
I'm sorry. So on my note, I have sine theta equal opposites over hypotenuse, and the cosine theta equal adjacent over hypotenuse. This is what I have.
For sine, it's opposite over hypotenuse, and for cosine, it's adjacent over hypotenuse. Do you know what SOHCAHTOA is?
Yes, it's here. This is, you see,
Oh,
it's,
nice.
you see it said right here. SOHCAHTOA.
Oh, nice.
So I think it says something. S is the
That's sine, and then it's opposite over hypotenuse, and then the C is cosine, and it's adjacent over hypotenuse. And the T is tangent, and then opposite over adjacent.
then I just forget everything. I used to study hard for this, but now it just everything blank on me.
You're all good. Maybe add a little note. Maybe it'll help you remember.
I need to review a lot of things. I cannot go so quick.
It is okay. I don't even know what I'm doing, to be honest.
No, you're good. You got
We're in the same boat. No worries. So we have to solve for
cosine theta.
cosine.
So right now we have sine theta equal 0.030.
So what was that? I'm sorry, you cut off.
Oh, the question was sine theta equal 0.30.
Mm-hmm.
Then I don't know what are we supposed to do next. Something opposite over hypotenuse, or we need to simplify it or something.
We need to find cosine theta.
But how do we need to draw the angle triangle?
Do not know. That's the thing. I'm gonna ask my mom. She's really good at math.
What you guys majoring?
What was that?
What are you studying?
I'm studying architecture, so I'm just getting started. How about you?
Require a lot of math too, right?
Mm-hmm.
Mostly, what do you study? What math class are you taking? Like all of them?
What was that?
Oh, architecture. What math class requirement classes like?
So next semester or this semester, the one that's coming up, I'm taking trigonometry and pre-calculus. And then I'm gonna have to do applied calculus. And then after that, or while I'm doing that, I'm gonna do physics.
Oh, they require like Cal 1, Cal 2, Cal 3 linear algebra and differential? No?
I don't know if I have to do algebra.
For architecture?
For architecture, I think it's just applied calculus. I'm gonna have to review algebra.
And then you'll be finished with the math. I thought you require a lot of math for architecture.
I have no idea. I have to look back on my plan. Wait, Mama.
Actually,
Oh, it's again. Get out of here. Sorry, go ahead.
I'm taking a physics.
Are you taking physics? Cool. What do you want to do with your degree?
I'm not just learning physics, see whatever comes, and
Oh,
then
nice.
no. I took like calculus 3 times. Oh my god!
Oh man. You know what? I don't blame you. My sister, she took calculus last semester and I saw her doing like derivatives and stuff. And I was like, yeah, I'm not gonna pass. Now I gotta try really, really hard in that class. So we're all there. Calculus is not easy at all.
It's the one that depend on the professor.
Mhm.
That I had is like
Not too good.
no, she's very sharp. So every mathematic like algebra,
Mhm.
trigonometry, pre-calc, she really hit on the spot. There's no skipping.
Oh,
Just
man.
come to algebra, you gotta know your algebra. There's no skip back and forth. So man, it was so tough. And then yes, and the third time I didn't go back to that, so I kind of get the concept. So it's not.
Okay, at least you kept trying. That's good.
Yeah, my age, I'm getting old too.
Look at that. You're as young as ever. The fact that you're still in school is really cool.
This
A lot
is
of
my
people-
fifth year at Skyline, you believe it?
That's not bad at all. No, that's pretty good.
That's so embarrassing.
No, it's not. It's not embarrassing at all. You're doing a great job.
No, I don't think so.
I think so. A lot of people would just give up, but you're still pushing. So you should be proud of yourself.
Yeah, I don't know. It's not easy, man.
It's definitely not easy, but you're doing well. The fact that you're here and you're putting in the extra time, you're doing very well.
So what physics are you taking 210?
I'm not taking physics quite yet. I'm taking it the following semester. I'm going into trigonometry and pre-calculus. Trying to see what I'm getting myself into.
Oh, that's why this class, we have a lot of trick in here.
I don't even know trigonometry, so I'm sorry.
This is okay. Come to identity, it's gonna be, I tell you.
Mhm.
A lot of students just have no idea. But the concept is there. Once you have a formula, you okay?
Yeah, it's a lot of memorizing. All right, hold on. I'm gonna ask my mom how to do this really quickly. All right, I'll be right back.
Okay. James and Juliana, did you do it?
I figured out sine theta is equal opposite over hypotenuse.
Well, you didn't have to go that far now because I gave you the sign, right? I said sine of the angle.
Equal 1 or something.
No, we were dealing with I didn't tell you what the angle was. I said it was 0.3. Is that what I said?
Yes, correct. 0.3, correct.
That's what I said. And I said, what is the cosine of that? Well, you know that sine squared of the theta plus cosine squared of theta is equal to 1, right?
Mhm.
So if I substitute from here, I get 0.3 squared
Oh,
plus
yeah. Oh,
cosine square of theta is equal to 1. That tells you what the cosine is going to be. Easy. But it's
so Professor, let's say finish it. If I finish it, what will be the answer on this one?
well, let's do that. The answer would be cosine of theta would be a square root of 1 minus, if you square that, you get 0.09. This would be square root of 0.91.
Where did square root go, you know, on the cosine square?
Well, if I have a square, when I take a square root of it.
Oh, right. So do we need like plus and minus, something like that?
No, we're in the, everything is in the first quarter. We are doing the triangles right now.
All right. Thank you, Professor. Thank you.
You're welcome. All right. Okay, now, where is Tina? Tina, did you do it?
Yeah,
What did you get?
41
41 what?
meters.
Okay. What did you get, Jackie?
41 meters as well.
And Isabella?
For
For the length of the flagpole.
the one that you left us with.
Yeah.
I think I just have it in non-calculated terms, but let me calculate it.
You can just take your time later. That's okay. And Ned, what'd you get?
I left it in uncalculated terms.
And
We got 130. Oh, wait, we got 136.
I have 41.
Oh, that's
Well,
different. I was looking at a different one. Never mind.
So let's do it for 1 second, okay? The first thing you have to do is that to figure out from before we figured out what the, well, we know what this angle is, right? Is that correct?
Yep.
Okay. Now, we know this was 35, right? And we know this was D.
Can you use your other camera so we can see the board better?
Yeah. Can't you guys just stay about 2 extra minutes, Kevin and Isabel?
I can.
Okay, let me change the camera for a second because I want to do a better job. You could do a fancy way, but you could do the simple way. And I'm going to do a simple way. Previously, we came out that D was equal to X, right? That was from this part of the problem. And D is all the way from here to there. And this is the flagpole F. You notice that F is going to be equal to D minus X, right? Well, how much is X? Well, if I call this height from here to here, that's all I need to find. How much is this distance from there to there? Anybody knows?
It's
Well, let's
cosine
write
of
Let's
It-
call it, give it a letter H. H over X is going to be equal to,
cosine of 35.
I'm sorry, F is going to be B minus H. And this is going to be equal to the tangent of 35 degrees. Opposite over hypotenuse. Which means that H is going to be equal to X times tangent of 35 degrees. That means here the length of the flagpole is going to be D, D minus X times tangent, but X is equal to D, so with minus D times tangent of 35 degrees. How much is the tangent of 35 degrees? Somebody tell me.
Point seven,
How much?
0.7.
0.7. Okay, so let's write it down. F is going to be equal to D. How much was D? 137? Right? Meters times 1. I'm factoring out D. Well, maybe I should not do it too fast. F is going to be D times 1 minus tangent of 35 degrees, which is going to be equal to 137 meters times 1 minus, how much did you say was tangent was? Point
0.7.
what? 0.7? So if you multiply, this is 0.3 times that is about 41. 40. Somebody do it and tell me what you get. Do it your calculator.
41.1.
That's close enough. So we can work on that. Okay. I'd like to get a 1-minute feedback from you. What do you think of the class today? How did it work out for you so that I can change it tomorrow? Tomorrow we're going to be dealing with vectors. Anybody? Okay, let me start one at a time. Tina, what do you think? Was it useful?
Today's lesson, yeah, I think it was useful.
Okay, good. And Stelios?
Yeah, I mean, I thought it was pretty interesting. Yeah.
Okay, am I saying your name right?
Yeah, you are now. You got it.
Okay.
Stelios, yeah.
Okay, good. Jackie?
Yeah, it was good.
Don't
Very
lie to
helpful.
me. Don't lie to me. Because
It
when you
was
say-
helpful.
Okay, because if you tell me what is good, I build up on it. Okay? Isabella?
I found it very useful.
Cool. Juliana?
It was nice. I thought it was insightful.
Fantastic. James? Better this time?
Yes, earlier I thought it was something 1.5 with something because I'd done this, but I forgot. But it came out H over X, so I was something like that. That's what I thought.
Little by little coming back, right?
Yes.
Good.
We get the height. We need something like 1/2 with the base and something. But it's there. I just need to review it. Thank you, Professor.
Okay. Okay. Isabel?
I thought it was really helpful.
And of course, Kevin.
I thought the session was really interesting, especially with the Dell operator. Seeing the relationships was pretty cool.
Yeah, I think yeah. Now you have, it's going to be something that's going to stick with you now. And there are 2 super important applications right away, as I showed you. All right. So tomorrow I have a entire, we're gonna build on what we did today. With you guys, we're gonna be dealing with eventually getting to use of the Maxwell equations. And with the rest of you, we're gonna be dealing with vectors. You're gonna find vectors nice and easy, Juliana, don't worry, don't panic.
Try my best not to.
Okay. Any question? How many of you will be there in the morning? How many of you would be in the afternoon? How many of you in the evening? Just tell me.
I'll be there in the afternoon. In the morning, I do chemistry.
Okay, that's fine. And how about the rest of you? I'm trying to plan. That's why I'm asking.
Morning or evening, because I have work midday, so yeah.
Okay, so you're morning and evening, right?
Yeah, I mean, well,
Okay, here's what I'm going to do then. I'm going to do something in the morning. In the afternoon, we apply it. In the evening, we extend it. Okay, that way works for you. All right. So the one who cannot make it morning learns it by application of it. The one who in the afternoon, and the one who's gonna miss that afternoon is gonna learn it in the morning. Okay.
I can only come to the evening ones.
Okay. And you're the one who had a calculus one already, right?
Right.
Okay. Then we can work with you nicely. Don't worry about
Okay. Okay. Thank you.
it. Okay, fantastic. And Juliana, what's your situation?
I will try to make it in the morning, but if not, I'll only be here in the evening.
It will be afternoon and the evening.
No, I don't know about afternoon because I have work.
Oh, okay. Anytime you can make it, that would be fine.
Great. Thank you.
Okay. See you. Okay. See you guys later. Take care.
thank you, Professor. Have a good one. Have a good night.
Thank you.
See you.
Thank you, Professor. You have a night.
You too. Enjoy yourselves.
Have a great night.
Take care. I'm glad you enjoyed. Ned, you didn't tell me your feedback.
No, I said it was all good.
Was it good?
Yeah.
Good. I'm glad you had fun.
Good
All
night.
right. Take care.